to figure out the inverse of a relation or a function. And hopefully you went through this yesterday and found out that that poor mayor still did not get all his money back to what it was before he was taking a pay cut. So like this says, if a relation pairs elements in A of its domain to element B of its range, then the inverse reverses that. So whatever you would have for a table, when you have the inverse, those two things just swap position. That's what happens. Now what's important about that is the inputs become the outputs and the outputs become the inputs, which means the domain of the first one becomes the range of the second one, and the range of the first one becomes the domain of the second one. They actually swap those two positions out. So usually if they ask you about domain and range, what you want to do is go back to the original and say, okay, what was my domain and range here? Because all I have to do is flip those when I get talking about the inverse. So you went through all of that good stuff and found out there's two basic steps. It doesn't matter how hard the equation looks, you're always going to switch the x and the y and you're going to solve for y. And part of this is knowing that y is the f of x. You know, that's the output. F of x is just notation for the function. And so sometimes we have to think at first, okay, where'd the y go? Oh, that's an f of x. I'll just replace it with y. And then I'll use it as I go through there. And like I did in the homework, if when we're going through these and writing our inverses, we realize we're having to take an even root and we pop a plus or minus out of it, that means the inverse is not going to be a function. Now, different ways to tell if something is a function. First we had, for every input, there's exactly one output. But the second way to tell was the vertical line test. If you draw a vertical line anywhere on the graph and it hits it in more than one spot, then the inverse is not a function. So graphically we can get them as well. So this one says we're going to find an inverse function, and it starts us off thinking, okay, let's just stop domain and range right away. You know, how are we going to get this to work? So I'm looking at my f of x equals the square root of y minus 2, and I'm going to go ahead and write that as y equals the square root of x minus 2 right away. And I start thinking, okay, what do they mean by domain? Do I have to restrict the domain on this one? And the answer is yes. If we want to stay in the real number system, remember, this cannot be negative underneath here. So if it can't be negative, then it has to be greater than or equal to 0, because it could be 0. The square root of 0 is 0. It could be something positive. We can always find those square roots. But as soon as we get a negative under there, then we're talking about imaginary numbers. So I'm going to solve this little bugger just by adding 2 to both sides. And there's my domain, right there. My x's have to be greater than or equal to 2. Just to show you a little step here as we're getting closer and closer. We have like 68 days of school left. As you get closer and closer to pre-calculus, we actually write this in what's called the interval notation. And interval notation says if you want to include a point, use a square bracket. So we could say that 2 is really where this is going to start. And then we use a comma, and then we say, well, we want this to go on forever in the right, to the right. And that we use infinity for. And infinity always gets what's called an open bracket, meaning it is going to keep going forever. We really don't have a stopping point. For what we're doing right now, you're going to do this. That's where we start thinking in pre-calculus, and then we immediately go to the interval notation as we go through the year. And then the range. Well, if I just found the inputs, I can figure out where the outputs start. Because I said that I have to use numbers that are greater than or equal to 2, it seems to me the first number to use, and that's why I use this notation to show you this, is 2. If I put 2 in here, I should be able to figure out what the first number is that's going to pop out. And 2 minus 2 is 0, and the square root of 0 is 0. And remember, we're keeping everything positive by saying x has to be greater than or equal to 2. So this one, the notation would be, hey, now we're starting at 0, and we're going to go forever in the direction. positive. Now B says, okay, well you did all that, find the inverse. Because that's what this notation says. It's not raising it to a negative 1 power. It's saying, figure out what that inverse is. And so I go back up here where I had y equals the square root of x minus 2, and I say 2 steps. Switch the x and the y, and solve for y. Okay, well, to get to y, I have to get rid of that square root symbol. That means I'm going to have to square both sides. So x squared equals y minus 2. Now notice, that was not square root. So I'm not getting two outputs here. So far, so good. And then I just have to add 2 to both sides. So x squared plus 2 equals y. Now, I have it equal to y, but I look at the problem, and the problem said, what is f inverse? So they don't want me to label it y, they want me to label it f inverse so it looks fancy. Now, why even bother with that? Because what it says is the original was a function. And that's what that notation means. The original was a function. So we have the inverse as x squared plus 2. And then it says, what are the domain and range of f inverse? And we can really just shut off our brains here. Oops, I should put y there for the range of x. There we go. Here's why we could shut down our brains. We already know what they are. They're already up here. They're just in the wrong order. Because when you do domain and range of an inverse, you swap these two positions. So our domain is going to be our range from the first one. So x is going to be greater than or equal to 0. And our range flip-flops with the domain of the first one. So y will be greater than or equal to 2. So you find the domain and range of the original. Don't struggle with trying to figure it out when you write your inverse. Your domain and your range flip-flop. X's become y's and y's become x's. And then D says, is that inverse a function? I look over here, I don't see any plus or minuses. If I put a number in there, I'm getting one answer out. This one is a yes. This works. And my explanation would be for every input, comma, there is exactly one output plus u. Exactly one output. There's no plus or minus. Did not have to take the square root, the fourth root, the sixth root, any of that good stuff. All right. So it's always interesting to me how they make this look so much different than what we just did, but it's really taking us through the same thing. It says let g of x equals 6 minus 4x. So here's the first thing I'm going to do. I'm going to make that g of x a y. So I want to remember there are 2 steps. Switch the x and the y and solve for y. So A says, what are the domain and range of g? Can you see anything up there that would restrict the domain for us on this function? No. No, we don't have any even roots, and we don't have any divisions. So the domain is going to be all real numbers. And if the domain is all real numbers, well, that's a line. That's going to pop out all real numbers for an output. And it's a line because it's x to the first. All right, let's look at B. B says, what's the inverse of G? How do we do it? Switch the x and the y. Then what? Solve for y. So x minus 6 equals negative 4y. Divide everything by negative 4. Do a little simplifying. And usually the book will put those in slope-intercept form because it's a lot. All right. Well, it said, what is the inverse of g? G was a function, so I probably want to write this as g inverse. And that's because they said, what is the inverse of g? So now we've got our g inverse here. And then C says, how about your domain and range of g inverse? And one of the things that we'll do in pre-calculus when we have various domain and ranges that we're looking at is we'll use a little subscript here to stand for domain of G inverse, so that we know, hey, there's a difference from the original one that we have there. Again, it's not something we're going to take points off for this year if you don't do it, but it is helpful to see, hey, this was for the inverse. So, what are we going to put for the domain of the inverse? All reals, yeah, that's the range up here. And what are we going to put for the range of the inverse? All reals. Got it. D. Is this a function? Yes or no? See plus or minus anywhere in this problem. We're good. The inverse is a function. Yes, for every input. There is exactly one output. So we're watching for telling them no, which would come from whenever we take a square root of 4 through to 6 through any even root, but that wasn't happening with this. So one of the things that people will do if they're looking at the problem at the very beginning is look for anything like, oh, do they have an x squared? Because if there's an x squared, I'm going to have to take square root, and that means the inverse is not a function. Is there next to the 4th, or next to the 6th? And it just kind of gives you a heads up when you start about whether or not that inverse is going to be a function. When finding the inverse of real-world problems, you can't switch the variables. The variables mean something. I mean, if you have the formula for area of a triangle, area equals 1/2 base times height, you can't magically say, oh, the base is suddenly going to be the height. It doesn't work that way. So when we're doing real-world problems, anytime there's words involved, we can't switch the two variables. But what we can do is solve for the one that's not solved for. That's what we do. So we simply solve for the independent variable, which is the input. How do you know which is which? Area of a triangle says A equals 1/2 BH. The A is the dependent variable. We're saying if you put whatever you want in for B and H, then you'll get A. So what we're doing here is we're solving for the variable that's not already solved for. And we've got a for instance here. A equals pi r squared. It's solved for A. But that's not what I want to solve for if I'm looking for the inverse. For the inverse, the only other variable I have up here is r. So I want to figure out how do you get r. So I'd have to divide both sides by pi. And then I'd have to take the square root. And I'd have plus or minus the square root of A over pi equals r. Except this is a real world problem. Can the radius of a circle possibly be negative? No. So it would be silly to put that little plus or minus piece on here, and we would just drop that. So real world problems give us context, which means we can think through whether or not we should use that little plus or minus piece. So finding the inverse of a formula. It says the function d equals 4.9 t squared represents the distance d in meters that an object falls in t seconds due to Earth's gravity. Find the inverse of this function. How long in seconds does it take for the cliff diver shown to reach the water below? So we're starting with this. But the question is about how much time it's going to take them. All right. So that means I want t all by itself. So give me a way to start getting t all by itself. Yeah, let's get this out there first. Then we would square root. Now we put our thinking cap on. Time be negative. Yeah. So now we can leave that negative piece off of there. And then they wanted us to figure out for this person over here, who's not the most stable person, so they're cliff diving. Very, very dangerous. we would go ahead and put the 24 meters in there. Oops, I want to go check the label just to make sure they didn't pull a fast one on us. Represents the distance d in meters. So we can just go ahead and put the 24 over there and see what we get. So square root of 24 divided by 4.9. So about 2 points. Did they say what we should go on to? We'll go at 2.21 seconds. That's not so long. They could actually, get their scream in and not have to take another breath. That would be good. 2.21 seconds. Yeah, that's fine. It wouldn't need a second breath for the scream. That'd be good. All right, down here, the function d equals v squared over 19.6 relates the distance d in meters that an object has fallen to its velocity v in meters per second. Find the inverse of this function. What is the velocity of the cliff diver in meters per second as he enters the water? All right. Give me a step. What would you do? Which begs the question, can velocity be negative? Velocity, yeah. It depends on what science you're doing. A lot of science does require, because velocity is supposed to have both direction and a speed. And so we really should put that plus or minus piece on there. And since this person is going downward, it should be a negative velocity. The book kind of ignores that part, but I know in science class they really want us to let you know, okay, there is a positive and a negative velocity. Alrighty, so now we need to know about the cliff diver up there that jumped off. So what do? Put 24 in there. And let's see what that velocity is. So square root of 19.6 times 24. And since they're going down, negative 21.69 meters per square second. Meters per second for velocity. And we've got it. Now the book doesn't require the negative part, but like I said, I know your science teachers really appreciate it when they can put a little bit of this together with what you do in science. And downward velocity is negative. Alrighty, what do we have left? You know that for any function f, each x value in the domain corresponds to exactly one value in the range, and that's because it's a function. For every input, there's exactly one output. For a one-to-one function, which is even a little more special, it works both ways. Every input has exactly one output, and every output has exactly one input. So this is why they're asking us that question of, is the inverse a function? Because if it is, then we have a really special relationship, a one-to-one function. And you'll find out in pre-calculus and calculus that there's a lot of really cool math that can be done with one-to-one functions. So it's also true that each y value in the range corresponds to exactly one x value in the domain. A one-to-one function f has an inverse, f inverse, that is also a function. So if they're both functions, then they can have that nice one-to-one. And notice how it just shows us the domain and range swap and the domain and range swap. That's exactly what we were talking about earlier. So our key concept is, what if we want to see this nice swapping relationship? Well, we have to put this together with that brand new operation that you learned, which was composition. This is super cool, by the way. If f and f inverse are inverse functions, then f inverse of f of x equals x. Wait a minute. So here's what they're saying. We're going to do the composition. It's going to look all nasty and there'll be all kinds of math, but in the end our answer is going to be x. Absolutely. If they are both true functions, that's going to happen. But remember, functions are not commutative. So if we do f of f inverse and we get x, that doesn't mean the whole thing works. We also have to do it the other way. We have to do f inverse of f of x. But look at this. We already know what the answer is going to be. If we did our inverses correctly, it'll always come out as x. So it's kind of a cool way to check and see, is the math that I'm doing, is it working? So this says that the composition of a function and its inverse is essentially the identity function. And that's the identity x. Or, like it says, y equals x. Wait a minute. Isn't that what inverses are? Aren't they reflections in line y equals x? Yes, that's the whole connection piece. So if we do the composition of inverses, we're supposed to get x. That's what's supposed to happen. So let's take B. It says for f of x equals 1 over x minus 1, we are going to find the inverse, and then we're going to go ahead and do some verifying, and we've got some numbers they want us to look at here. But right away, before I even start, I'm thinking, I've got a problem number here. There's a number we can't use in f of x. What is it? 1. Can't put a 1 into that function. So now, I'm going to think ahead, and I'm actually going to find something we're not going to do. So I look at this one and I say, okay, f inverse of 1. Well, we might be able to do that. We didn't find the domain of f inverse yet. But I already know we can't do C, because 1 can't go into f. And remember, when we write these, this is the innermost parenthesis. And we just said we can't use 1, because 1's not in the domain. So this is undefined. So we already found some math we can't do. The other we might be able to do. We didn't find the inverse yet. So let's go find the inverse and let's see if we'll actually be able to use that. So y equals 1 over x minus 1. Give me the first step for inverses. Switch the x and the y. Then what do we do? Oh goodness, this looks messy. It's in the denominator. That's bad. You're never supposed to have what you're trying to solve for in the denominator, so you have to figure out a way to get rid of it. And I look at this and I think that is so close to being a proportion. Oh, look, I just made it a proportion. Now I can cross multiply. That's exactly what we want to do. Now, you can ask yourself, do I have to distribute the x? The answer would be no, you won't. This is multiplication. If we want to get rid of it, we can just divide. And then we'd add 1 to both sides. And we just found a new number we can't use. So f inverse is 1 over x plus 1. What number is out? So now I look at B, and I'm trying to tell if for f inverse they want me to put a 0 in here, because if this is a 0, I can't do this problem. Well, it's not a 0, it's a 1. Okay, we're going to be able to do this. So now, this was a couple of days ago. When they give you a number, well, you're supposed to put the number in the closest one to it, get an answer, and then put it in the other one, because again, these would be embedded. But this time we're saying we want to put that 1 in f inverse. We can do that. This works with 1. We can do that. So we need to do that. So 1 over 1 plus 1, that's going to be 2. But we're not done. And that's because after we find f inverse of 1, we still have to put that back into f. Is it okay to put a 2 back into our original function? Yes, that's perfectly fine. So, original function up here was 1 over x minus 1. Well, 2 minus 1 is 1. There's our answer. We get 1. But looking ahead, we don't get tricked into trying to do C. You know, hopefully if you started to do C, you'd go, wait a minute, I can't use 1. I can't do that. But you kind of want to take a look at that to begin with. You know, what's my domain? Hopefully that'll keep us from starting to do some math that we don't need to do. Alrighty, g of x is 4 over x plus 2. Domain, what can't we use? Negative 2 is out. Are they asking us to find g of negative 2 with any of these problems? Nope. 0 and the 0. So far so good. Looks like we're going to be able to do them. So let's go to A. We're finding the inverse. First step. Second step. So what's the easiest and fastest way to do that? Now, if you're wondering, because some of you I know work ahead, I watch you, I see what's going on. Well, I distributed the x. Is that going to be wrong? No, you're just going to have to do some division of the rest of this one. That's all. So we can divide by the x right now. And then subtract 2. And we want to write this as g inverse of x because that's what the problem is said to do. But I think we have a new issue. What's our new issue? Can't be 0. So, the domain for this one is x can't be 0. That just eliminates some work for us looking at B and C. Just B? Yeah, because remember, it's going in here first. Undefined, can't do it. Is it okay to put 0 in our original? Was that an okay thing? Okay, so that one we can do. Let's take B. If we put 0 in our original, we'll get 4 over 2, which is 2. Done? Walk away. What do we still have to do? Is it okay to put 2 into our inverse? Yeah, 0 was the problem. It wasn't 2. So 4 over 2 minus 2. So these problems, this is using everything that we've talked about so far. We're putting that composition together, domain and range, all of that good stuff. So, is that it for this page? That's it, huh? Now for the good stuff. The good stuff is verifying that the composition works, making sure that our inverse is truly right. It says for each function, find the inverse and the domain of the range of the function and its inverse. Determine whether or not the inverse is a function. Well, that's not what I was thinking was here. We didn't have to do the composition piece at all. Oh, that's right. This book doesn't. Oh, shoot. They're cheating out of some good math. Well,
yeah. What do you do?
It's good stuff.
Shoot.
All right, let's look at this one. It says for each function, find the inverse and the domain and range of the function and its inverse. So how would you start? Crying. Crying's not allowed. Remember, that's one of our rules. You never give up and there's no crying in math. What do you do? Switch the x and the y. Oops. So what's next? Let's say we had to name it something fancy. Probably should though, right? Yeah, f inverse since it was a function. Okay, let's talk domain and range. Anything we can't use in expert listing? No. But the range is like that, we're not using all the y's. We're just using the y's that are above 3. So that range is going to be x is greater than or equal to 3. So with this one, we want to think about that visual. Where is this graph going to be and what's it going to do? So now we need the domain of the inverse and the range of the inverse. Oh, did you say that too, Justin? I did it again. Put an X there. So what's our domain? What's our range? What else did they want? Oh, is the inverse function. What's wrong with it? How do we know this is not a function? Plus or minus. Inverse, not a function. Not. Whew. All right. It's a little different. Try this one. For each function, find the inverse and the domain and range of the function and its inverse. Determine whether the inverse is a function. Oh, same directions. Different problem though. All right. So I'm going to make this a y. Do we want to talk domain right away, or do we want to find the inverse right away? Domain? Negative x plus 5 has to be greater than or equal to what? 0. Uh-oh. This one's different. What do you have to do when you divide by negative? You have to flip the sign. Interesting. So there's our domain. So that makes me think, we maybe better take a look at this graph. Because it could be here that range-wise, something goofy is going to go on. Maybe covered square root graphs and exponential, but we haven't quite gotten there yet. So the easiest way for you to see this one would be to just plop it in your graph. Interesting. So our range is the y values. It starts at 0. Well, yeah, because if we put 0 in here, we're going to get the square root of 5. Yeah, so 0 sounds like that's a good deal. But is it above the y-axis or below it? It is above it, so y should be greater than or equal to 0. So a little more thinking when we start talking about our quadratics or our square root functions. All right, so we've got our domain set and ready to go. So let's go ahead and write our inverse. Step 1. Step 2. Square it. And this one was again called f of x. So let's use the right notation here. Looks like that. Interesting. So if we switch our domain and range like we're supposed to, let's make sure it makes sense. So let's see this one. See what happens with this graph that would make that true. We should already know because you guys did study quadratics quite a bit. So does it make sense that our x values are greater than or equal to 0 and that y is less than or equal to 5? Well, we look at this and think, but I have some x's over there in the negative land. Originally, they only wanted the principal root, so that's why we see that piece. So again, taking a look at it is always a good idea. Always a good idea. Oops. Yeah, put that there. That's everything.
Wow.
It was a long one. It was a long one. 43210 inverses. Using the composition. Yeah, that's a lot to keep track of, isn't it?
Yeah.
Site.
There we go.
39 is quite a bit. I think we could trim that down a little bit.
It's just inverses. Switch the x and the y and solve for y. Oh, and it is graphic.
Oh, 21 to 39.
21 to 29.
Oh, you should trim it down.
Just make it the odds. How about that? Be nice. Keep proving that we
No, we've got to get back into knowing what square roots look like and knowing what squaring looks like. So,
This assignment's gonna take like 3 hours.
oh, it is not.
This assignment's gonna take like 3 hours, Jack. I think we should have a night off.
Did you have a lot of work time yesterday?
Yeah.
Yeah.
Understand why they show up in my car. Oh, you can grab.
Oh, no.
Yeah. Okay.
Well, you have a graphing calculator, so you can graph on your graphing calculator, and then you can just transfer it over onto paper.
Well,
But it's really important that we get those visuals back into our mind of, hey, here's a line, here's what a quadratic looks like. Thank you, Jack. Here's what a square root function looks like.
Shoot.